Hi, welcome to Section 3.1 Intro to Logical Arguments, Part 3. In this video, we're going to talk about arguments with not, with some, and arguments called transitivity. So we're going to start with this one. This is an argument with the word not in it. If it's green, then it's not a dog. It is green, therefore it is not a dog. Does that seem valid to you? Like the conclusion here follows from these two? Think about it for a second. And then we're going to examine it both with symbols and the picture. So to rewrite the argument in symbols, we're going to use this little not symbol. It's very similar to the complement in sets. And if you put it not in front of D, it means not a dog. So the letter D means it's a dog. And then you put this in front, not D means not a dog. So try for a second, stop the video for a second and try to write this statement out in symbols on your own. Okay, hopefully you did try it. And here goes. So it would look like this. Here's the symbols. If it's green, then it's not a dog. Looks like G, arrow, not D. It is green, that's G, and the conclusion is therefore not D. And I've also rewritten it here as how you would write it if you wanted to make the Euler diagram. You would put a name back into it. So it just says dog, you would name the dog. And see if you can draw a picture for no dogs are green. So here you have the symbols that I asked you to try. Now try the picture on your own. Pause the video for a second. Remember, no isn't the same as some or all. So no has two separate circles, and this is what this would look like. Here's Henry. Henry has to be inside green things. Henry cannot be out here because the premise is it is green or Henry is green. So it has to be inside green things. And is this a valid argument? Yeah, I've already given away. This is valid. Why is this argument valid? Whoops. Because look at the order. The first thing happened. The first thing, therefore the second thing is not D. First thing is G. It matches exactly. Therefore the second thing, which matches exactly, happened. And it's valid. It's also valid because the H cannot be in here. The H has to be inside green things because it says Henry is green. So therefore, it's true that Henry cannot be inside the dog's circle. Now here's one for you to think about, whether it's valid or not valid. If it is green, then it's not a dog. It is green, therefore it is not a dog. Does this follow the same correct order? Oops, actually, my bad. Sorry, I already told you this was valid. This one is valid because here we go. The first thing's G, followed by not D. First thing G happens. Second thing not D must be true. I wondered where those things had gone. So now you have a nice map as to why it's valid, right? It follows the correct order. And the Euler diagram looks like this, which we talked about before, and excludes Henry from the dog circle. So it is a valid argument. All right, now we're going to try a different one. So if it's green, then it's not a dog. It is not green, not G. Therefore, it is not a dog. What do you think? Valid or invalid? Pause the video for a second and see if you can tell. Right now, just use the order to see if you can tell. And then think about maybe drawing a picture to see also if you can tell. So if you didn't pause the video yet, pause it now. And I'm about to go over the answer in now. So here goes the answer. First thing's G, followed by not D. G does not happen. So the second thing, not D, does not necessarily follow. No. This is not a valid argument. It does not follow the correct order. It would have to be G here. Not G. That doesn't work. And let's look at the picture. So if you didn't try the picture yet, try the picture now. Remember, no dogs are green, 2 separate circles. And the Euler diagram would be something like Kelly. You'd have to name K for Kelly. That's why I have a K waiting for here. And you'd have to say, therefore, Kelly is not a dog. Is that true or not true? So think about where you would put Kelly. The hint is that K is in 2 different spots, but what are those spots? So for this one, again, really pause the video. I'm about to go over the answer. Okay, here goes the answer. So, no dogs are green, 2 separate circles. Kelly is not green. Kelly could be here, outside of green. Remember Henry, who is in green? Kelly has to be outside of green. But this is also a spot that's outside of green. So there are 2 spots. This is the spot where Kelly is not a dog, and this is the spot where Kelly is a dog. Since Kelly can be in 2 separate places, the conclusion does not necessarily follow. We can't be 100% sure. So this is invalid because K could be in the dog circle. All right, we're going to do 2 last types. This one is some cats are pets. Again, see if you can pause the video and figure out how to write some cats are pets and Fluffy is a cat, and see where Fluffy goes. Again, people have a lot of trouble placing people in some circles or placing objects inside of some circles. So really pause the video right now and see if you can draw this. Okay, here comes the answer. And even if you get this wrong, the important part is you tried it out, and whether or not you got it wrong will inform how you're going to think about it next. So here's Fluffy as a cat. Because the cat circle overlaps with the pet circle, there are 2 spots in the cat circle where Fluffy could be. Fluffy could be here or here. So what's that mean about the conclusion? Valid? No, it's invalid. Fluffy, or F, could be part of the cat circle that's outside of pets here. So like Fluffy is a lion, right? Not a pet. Now notice we're not going to change the argument into symbols because you can't. A some statement does not translate into the conditional. Some cats are pets is not the same as C arrow P. That would be all cats are pets, which is not true. You know that, right? So be careful. People love using the symbols. They love the conditional. I like the conditional. It's like sometimes it's easier than the pictures, right? But you can't use it with a some statement. It doesn't work. So the important piece of that is to know which tool to use at a given time. Okay, last thing. All and transitivity. So see if you can come up with the correct conclusion here that's going to create a valid argument. All squares are rectangles. That's squares inside of rectangles. All rectangles are quadrilaterals. That's rectangles inside of quadrilaterals. Therefore, all what are what? What's the logical correct conclusion here? Pause the video or think about it while I'm talking for a second here and see if you can figure it out. The correct conclusion is going to create a valid argument. Correct conclusion is therefore all squares are quadrilaterals, because all squares are inside of the quadrilateral circle. Now let's use the arrows now. If it's a square, then it's a rectangle. What's the next one going to be? All rectangles are quadrilaterals. How does that translate into if then? Next one's going to be, if it's a rectangle, then it's a quadrilateral, R to Q. And the conclusion is, therefore, if it's a square, it's a quadrilateral. That's a valid, correct conclusion. And the reason it's valid is by something that's called transitivity. Notice how we have S going to R, R going to Q, and then S going to Q. So the symbols are in an order. S to R and R to Q, which means that S goes to R goes to Q. This type of argument A to B, B to C, therefore A goes to C, is called transitivity, valid argument by transitivity. If we had this in symbols, it would be something like 3 is less than 4, 4 is less than 5, so 3 is less than 4 is less than 5, right? So the same thing here. It makes a little chain. Whoops, up here, A to B, B to C, so A to B to C. In other words, A to C. Look at this one though, A to B, C to B. Can you conclude A to C? No, because it doesn't go A to B and then B doesn't go to C. It's backwards here. It needs to be A to B and then B goes to C. So you need to show a chain going from one end to the other. Now here's one last one for you guys to try. And this is with the picture that we know, the rationals, integers, whole numbers, natural numbers. Is the following argument valid? All whole numbers are integers. It's true. Whole numbers are inside of integers. All natural numbers are integers. That's true. Natural numbers is inside of integers. So then my conclusion, therefore, all whole numbers are natural numbers. Look at the picture and see if it's true. All whole numbers are natural numbers is not true. It's backwards, right? Natural numbers is inside whole numbers. So you can see that it's invalid just from looking at the diagram. But you can also see that it's invalid looking at the symbols. W goes to I and N goes to I. There's no chain from W to N. Each arrow points to I. Nothing points to N. There's no chain that gets us to N. Now, typically with this one, transitivity, a lot of people, so some people get it right away. Some people get it after a little bit of thought. And for some people, it's really sticky to try to get it. It just takes a little extra work. And so what I want you to try is there's some fun puzzles at the end of this section, a bunch of different ones, 3 different ones to tell if it's valid or not. And I want you to try them out. And then look at the answers and see if you can figure out how come the answers worked the way they did. Now, the puzzles that I have in 3.5 have extra stuff like distractors that you can ignore, extra lines, and things you can just cross out, and the order might be messed up, but it doesn't matter. It should still follow a chain, a logical chain. If I have the conclusion W to N, it's supposed to go from W to something, and that something goes to N, which this doesn't do. So see if you can find those in the puzzlers, and that's going to really help you stretch your brain a little bit and really get this part. So I will see you in the discussions. Bye.